This is the 2019 higher level question C1. It is the geologic geometry question, and this contour map is on the back of the section A's with the question then located in the exam paper in section C, the first question in there, which is visible on the screen at the moment. So the accompanying map shows ground contours at 5 meter intervals, so each is going to rise or fall 5 meters. ABC is the central line of proposed track for motocross bikes. D, E, F and G is a proposed pit stop area. O is the center of the circular curve. So the specifications: the portion from A to B is level at an altitude of 55 meters. That's the curved section. Portion from B to C is rising uniformly to a level of 60 meters at the finish line C. And then the formation level at F in the pit stop area is 55 meters, and the gradient from F to E is the same as that of the track from B to C. So using side slopes of 1 and 1 for the cutting and 1 and 2 for the embankments, complete the earthworks necessary to accommodate the track and pit stop area between A and C on each side. Part B then we'll look at in a moment. So this is the contour map located on the back of the section A, and we're going to start by doing the section from A to B. So we're told that the height of the road is at 55 meters, so everything that is below 55 is going to be an embankment, and everything above it is building it up. So at this point here, so I'm just going to locate the 55 contour, so that's here and here. Everything on this side of it is lower than 55, everything on this side of it appears to be higher than it, so there's the other 55s as well. So this bit is going to be cut, this is an embankment. So for our slopes, we're going to be taking, we're going to start with the embankment, and the embankment has a side slope of 1 and 2. So I'm just going to take a line out here through O, anywhere out to the side of it, and I'm going to measure distances out the side. So the side of the road here is 55, and they're 5 meter contours, so that means we're going to use 10 meter sections. So for every 5 meters that we go down, we must push the ground out. For every 5 down, we must push the road out 10. So that's 50, 45, 40, 35 appears to be the lowest one. So from there, we're going to take our compass and draw the arc. So center on O. Swinging these around just up to in line with that area there. And the 35 as well. So I'm just going to label each of these heights. So 55 is the edge of the road, 50, 45, 40 and 35. Each place that any of these lines intersects with a contour of the same level is a point on our embankment. So this is 40, next one goes off it. This is also the height of 40. This one is at a height of 45, so that's hitting the 45 height line. This one hits 55, and then it comes into the side of the road. So joining up our lines here, and that is the side here for the embankment on the west side of the road. So just drawing in the water pipes with those flowing down. Same thing on this side. So again, we're just measuring in distances of 10 because this is again an embankment. And again, going to draw our arcs with the point of the compass on point O. That's the center of the curve. So that was 55, 50, 45, 40, and 35. So again, label the points just so you don't get confused. 45, 50, side of the road is 55. So 35, that's this point. This is 40, 45, 50. So edge of the road coming in along this way, into the edge of the road there. and that is our embankment section. Next part of this is again the same lines. We're dealing with our road that is level, the curved part of the road. This time it is a cut because the ground contours are higher than the 55, and for the cutting it's a slope of 1 in 1. So again, I'm just going to take a line out through out up here somewhere, doesn't matter where, and I'm just going to measure out along there. So as it's height changing of 1 in 1, their contours are 5 meters, so we're just stepping out distances of 5. So for every 5 meters that we're going up, we're pushing the ground back 5 as well. And I'll mark the same on the inside of the curve as well. There and there. So this one, 55 for the side of the road, 60, 65, same on the opposite side of the road. There and there, so 55, 60, 65. So again, 55 here is at the side of the road, hits the 60 contour, 65, 65, 60, down to 55. Same on the opposite side, 55, hits 60, hits 65, 65, 60, and back in. So this is the cut, and that gives us the embankment down here for this part of the level road, and then the cut for the same part of the road there. So that's the first part of this with the level road. Now we're dealing with a road that's inclining at an angle, and it is rising uniformly from B to C to a height of 60. So it's at 50, 55 here at B, and it's going to end up here at 60. So as this road is rising, we need to put in our cones to take account of this. Everything here is less than the height of the road, so all of this is going to be an embankment. We're filling it up. When we're putting in a fill cone, it goes on the high point. So as this is changing at an altitude of 5 meters, and for our embankments we are using side slopes of 1 and 2, our cone is going to be radius 10. So that's based on this distance. The change in height between B and C is 5 meters. Side slopes 1 and 2, 1 times 5 is 5, 1 times 2, or 5 times 2 is going to be 10. So we're going with radius 10 out here at the end from point C. So putting that cone up there, and we're going to join this point now, so tangential back to the 55 height. So the height of that height line there is 55, and then we're going to step them out on intervals that are the same as what we've been doing for the other embankments. So they're intervals of 10, so that's going to be 50, 45, 40 and 35. Taking lines parallel to our orange line here, our height line. So each line out along this way. So that's 50. The next one is 45, 40, and then 35. Again, anywhere our height line interacts with a contour of the same height as a point on our embankment. So this point here is 50, that's going to be inside it. So 50, that's this point here. 45 is this one. 40 and the 40 contour. 35, 35, 40, 45. This one here is 50 and 55 off up in here. So our embankment on this side for the sloping road is going to look like this. So all I did here is the change in height between B and C is 5 meters. As it's a slope of 1 and 2 for our embankment, 5 times 1 is 5, 5 times 2 is 10, so the radius here needs to be 10. For the cone, an upright cone, and then it's join this back to the height 55, that's our height line for 55, and then all other height lines are going to go parallel to that, the 10 meters out, because for every 5 that we're going down, we're pushing the ground back 10. Same thing is going to happen on the north side of the pit stop area. So again, same size radius from point E, this time going to give us the exact same thing. This is going to join back to point F, because F is at the same height as B. And we're doing the same over here, so this is also 55. Stepping out our 10 meter intervals, 50, 45, 40. And we might need the 35 would do. So going parallel again. Height line here of 50, 45, 40 and 35. May need it, may not. 35. So again, wherever the point E here, that's 60. The next one out, 55, is this point where the height line meets a contour of the same height. 50, 45, 40, 35 and 35 off of there. So again, joining our points up. Now I'm just going to draw this last bit in lightly because I don't know how that's going to interact with the side of the piece here now as well. So that's the taking into account the rise coming along FE here. The final part of it then is to take into account the edge of this GF. Now GF is level, so GF is the pit stop is inclining this way, it's not inclining this way it's horizontal, it's level. So we're going to treat this just like any normal piece. So if it's at 55, the contours outside of this are less than it. So this is 50, this is 45, and so on down to 40. So this is an embankment, same as what the rest of it has been. So taking our lines out this way, 1 and 10 again, or 1 and 2, so 5 and 10, out along this way, parallel to the edge of the pit stop area. Use blue. So that there, this is 55, this is 50, 45, 40, and I think I need to go a little bit further. 55, 50, 45, 40, and just do it there to 35. And 35. So again, where the same height lines meet. So this is this one. So this one here is 50, 45. This one over here is 40. We've got 35 and another 35 here. So edge of our embankment here is coming along this way, out along here, up and around, and then it's going to cross through the other one that we've already found. So it's light on the other side, and then I can just darken in this little bit coming back here. Gives us that much. Now the final bit here is there are two different directions, so we need to join from point F down to where the two lines cross over here, because there's going to be a change in the earth bank there. So that completes this first part of question A. of C1 question A. So part B of this question is dealing with stratums of ore. So on the map, P, Q and R are 3 points on the top surface of a stratum of ore. Q and R are at altitudes of 40 and 25 respectively. The stratum has an altitude, or has a strike of north 54 west as indicated on the given strike line. Using the given x1y line already drawn on the map, determine the dip of the stratum. Part 2 of this is then to find the altitude of point P in space provided at the top of the map. Draw the elevation of the triangular portion of the top surface, and then determine the true angle between the line P and R and the strike line S. So having a look at this, I'm just going to zoom in on this section. So for part B, we've already been given our strike line. That's this blue line coming along here. So what we know with our strike line, if I take a line perpendicular, looking along this, and then project it off out here into our x1, y1 line, I will be able to find the dip of this plane, of the plane PQR. So lining up here, going perpendicular, which is also perpendicular to our x1, y1 line, taking each point P, Q and R out along this way. We are told in the question that Q and R are at altitudes of 40 and 25 respectively. So 25 we're given is point R, and you can see up in this one that this is the lowest point. So I can mark point R down here as the lowest one of 25. And point Q has an altitude of 40. So 25 minus the 40 is going to give us 15. So it's 15 meters here above that one there. So now if I take a line, this is R, this is Q. If I take a line through those, this is an edge view of that plane. What this finds for us is the dip. So this angle in here is the dip that we were looking for. So that's the first part of this. The second part of this question is locating the altitude for point P. So to find the altitude for point P, what I'm going to do up here in the elevation of this first, I'm going to draw height lines. They've already given us one at 25, so I'm going to continue up further with that. So we got 30, 35, 40. So height lines up here. So we're going to project point R, we've already found that one, point Q, which we have at an altitude of 40. So project this one up. So that was 25, 30, 35, 40, 45, 50, 55, 60. So up at an altitude of 40 is that point there. And we already have the height of point P. So when we find our view off down over here, PQ and R, we see an edge view of them. So if we project point P up along this way, and where the strike line, the edge view of that plane intersects that, that gives us this height here. So we can take this height, that height there, that's the height that we're looking for. So when you project that up here into the elevation of this view, we can locate the top point for P. So we can measure that height here with the compass or with your set square, whatever works. Mark that up onto the line for point P here from the 25. And that's up another 5 millimeters above the other ones. So that's at an altitude of 65. So point P is up here, altitude of 65. So point Q is this one, Q Q, and R. So we've located the altitude now of point P, and we can draw the elevation of the triangular surface here, P, Q, and R. So that is the final point there for point P. That height is based on this height here, so from that 25 line up to the top is the same height that this is down here. Final part of this question is to determine the true angle between the line PR and the strike line S. So what we have at the moment is we have a plane that's tilted down like this. R is down low, P is up high. What we want to do is we need to rotate that so that it's horizontal, as our strike line is a horizontal line. Once we have that, with this being our strike line, we can see the true angle between them. When it's tilted down like that, we can't, but if it's horizontal, we can. The best place to do that is if we have an edge view of the plane, and we already have that. We have that in this view off over here. So what I'm going to do is I'm going to take an edge view of this plane, rotate it until it's horizontal, or well, parallel to the X1, Y1 line, and then project each point P and R back, and that will give me the true angle between the strike and the line PR. So first thing that I'm going to do is I'm going to take a line parallel to X1, Y1, and I'm going to do that through point S, or sorry, through where Q and S are, so kind of through point Q up here. So a line this way. So that is it in its finished position, but we need to rotate it. So as using point Q here, because we're rotating around the strike around that line. So taking point Q, pencil on P, rotate that down onto that line. Doing the same thing for point R on this side, taking this point and rotating that up here. This line, that green line there is this plane PQR after being rotated. Sorry, I didn't go further enough on this side. So this is Q1, that's the new point Q, this is the new R1. Sorry, that's point P. That's P1, R1, and Q there in the center. I'm going to project these back up this way. So point P and R, and then each of these points is going to move, it's rotating, so they're moving perpendicular to the axis that they're rotating around, which is the strike. So perpendicular to the strike, so point R is moving in this direction outlined that way. P is doing the same, perpendicular to the strike. So this point here is P1, this point out here is R1. Drawing a line between the two. That green line there is it in its new position, and then between the green line and the strike is the angle that we're looking for the true angle between the line PR and the strike line S. So that completes this question. It is the 2019 higher level question C1.